Okay, here we go. Starting chapter 7. Hopefully you guys did pretty well on your test yesterday. Should be a pretty short and sweet video note section. So let's go ahead and get started. We're going to apply the Pythagorean theorem today. Most of you guys are already really familiar with the Pythagorean theorem. But basically, if you have a right triangle, you know that you have now a squared plus b squared is equal to c squared. Okay, again, not anything that you're completely unaware of, but the key is the whole deal with the right triangle, right? We have to make sure we have a right triangle. And the other thing is the hypotenuse is always across from the largest angle. It's the longest side, and it only makes sense that it's to be across from the largest angle, right? Somebody told me, or somebody asked me today during the test something about how do I know which angle goes with what side or whatever the case is. Basically, let's say you have sides of the length 4, 6, and 10, okay? Your largest side of 10 is going to go with your largest angle. Your 6 is that medium side. It's going to go with your medium angle, and your 4 is your small side. It's going to go with your small angle. So it kind of works out that way. And we're talking about the angles that are actually directly across from those legs. And speaking of legs, you have your two legs, which are A and B in this situation, and it doesn't really matter which direction that which one's A and which one's B. But when you're talking about a right triangle, you're dealing with your legs being the height and the base of your triangle. Okay? All right, so let's look at this. Basically, what you're looking at here, this is a mathematical proof of the Pythagorean theorem. You have a square inside another square, but what this proof does is basically what it says is that if Pythagorean theorem works, then the area of your square, okay, is going to be equal to the area of the four triangles plus the area of the square, okay? So let's take a look at this. So to find the area of a square, I'm going to have area equals side squared, right? In this case, my side would be A plus B, right? So I'm going to square that. So the area of a side is A plus B squared. And that should equal, like I said, if I do this right, 4 times half AB plus, and I'm going to write on my drawing, so don't stress. I'm going to write about the drawing. So 4 times half AB plus the area of the square on the inside, which is side squared, which is going to be C squared. Okay, and the reason I got 4 half A plus B, A times B, is that half A times B is the area of all of your 4 triangles. And there's 4 of them, so that's why you multiply it by 4. So let's see if these two balance out. Okay, if I want to do A plus B squared, I'm going to have to FOIL. So I'm going to have A plus B times A plus B. And when I FOIL that out, it comes out to be A squared plus 2AB plus B squared. So I skipped some steps there, but trust me that that's how it comes out. Okay, and I'm actually going to move that down so we have more space to work. So you have A squared plus 2AB plus B squared. And that should be equal to, if I work this out, 4 times half is 2AB plus C squared, right? If I work this out, what do you notice? You have 2AB on both sides, right? Those are going to cancel each other out, leaving you with A squared plus B squared equals C squared. Thus, in point, the case of Pythagorean theorem. And that's how you get the Pythagorean theorem. And that's, again, a mathematical proof to prove that it actually works. Okay? All right, with this section, we're also going to be dealing with some things called the Pythagorean triples. Those are 3 positive integers that satisfy A squared plus B squared equals C squared. What is an integer? Yeah, that's a whole number, right? A squared plus B squared equals C squared. We're talking about whole numbers, not talking about any decimals or anything like that. Some of your most common Pythagorean triples are 3, 4, 5. And you can have variations of that, but these will work. And some of the variations might be if you see 6, 8, 10. How do you know that that goes with that is a Pythagorean triple? Because 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10, right? What about 9, 12, 15? That'll also work. 3 times 3, 4 times 3, 5 times 3. Okay? So basically you could take your triple and you could multiply it by whatever, and as long as they all work out equally and they're multiplied by the same number, those Pythagorean triples will work. So let's look at another one. Like 5, 12, 13 is another common Pythagorean triple. So if I multiply it by 2, all of them by 2, I have 10, 24, and 26. Multiply all of them by 3, I get 15, 36, and 39. Those are all Pythagorean triples. Okay, because they're just variations. These ones down here and these ones down here are just variations of these two right here, right? You can do the same thing with 7, 24, and 25. That's a Pythagorean triple, not as common as the others, but it's 14, 48, and 50. If I multiply by 2, if I multiply by 3, you got 21, 72, and 75. Again, all variations of this first one here. Couple more, we got 8, 15, and 17. Multiply by 2, you have 16, 30, and 34. Multiply by 3, you have 24, 45, and 51. Again, all variations of this here. Last but not least, you have 9, 40, and 41. And you multiply by 2, you get 18, 80, 82. And 27, 120, and 123. Okay, so those are all Pythagorean triples, and they all basically are like, it's like kind of like a family tree. This one, the 3, 4, 5, basically creates these 6, 6, 8, 10, 9, 12, 15, and so on and so forth. Why do we just spend time basically babbling on about the Pythagorean triples? Because here's the deal: if you can identify those quickly and I'm not saying memorize all of them, but if you can at least memorize the top ones, the circled ones, then you know that any variation of those circled ones is going to give you a Pythagorean triple. That keeps you from having to do the Pythagorean theorem. It's kind of a shortcut, so that way you don't have to, okay, let me test 18, 80, and 82. Let me throw them in there, see if they balance out. Instead, you just know that because it's a variation of 9, 40, and 41, you're good to go. So basically, that's all we're dealing with in this first unit, applying that Pythagorean theorem. And then the Pythagorean triple, of course, don't underestimate the section. Make sure you're doing all your homework. But of course, it's going to be a little more challenging than that as you're doing your homework. But if you have any questions or any concerns, come see me in tutoring. Other than that, I will see you guys tomorrow, and have a great evening.